It's time to start monitoring the quality of the data that comes into our endpoint. To do that, let me show you here the diagram that we've been using so far. So we're going to be focusing on the top portion of this diagram where I have the data monitoring piece. In the past few sessions, we built or we extended the pipeline with this quality check step to compute the baseline of what the data that we should be able to process looks like. Remember that that quality check step generated a constraints.json file and a statistics.json file. We saved those baseline metrics in an S3 bucket, so we have access to them. What we are going to do today is we're going to create a monitoring job that will take care of using those statistics, using those baseline metrics, is going to start continuously monitoring the data that comes into the endpoint. What is that data monitoring job going to get the data from? Well, it's going to get the data from the captured data from the endpoint. Remember when we created the model, when we deployed the model, we started capturing the data. We configured the model to start capturing the data and start saving all of that data in S3. So now we can have a data monitoring job that will continuously take the data that comes into the endpoint and compare that data with the baseline metrics. And if it finds any violations, it's going to report those. And the way it reports those violations is number one, to CloudWatch, so we can just generate charts and see how the data looks like and all of the violations. I'm going to show you how to do that. And number two, it will also generate all of that data. It will save it in S3 so you can process that data however you want. Okay, so this is what we're going to be focusing on today, setting up those monitoring jobs. Let's go back to the code at session 18. So the first step will be to create a function. I'm going to create a function here that I will later reuse, and that function will allow me to deploy a model to an endpoint. You've seen this code before. I'm creating this function here so I do not depend on a pipeline. In a production application, we would have a pipeline, and that pipeline will maybe automatically deploy the model, and then we can have the monitoring part separate. I just don't want to run a pipeline just to show you the monitoring process. That's why I'm just deploying the model here manually. I'm just going to create this function using the same code that you've seen before, and I'm going to deploy the model manually, and then I'm going to run the monitoring process just so you see how monitoring works. This function, first, it's going to list all of the model packages from a specific package group. I'm using the pipeline model. So I'm just listing that, getting the top one. So the latest model basically that I created. And then I'm going to be creating a model package out of that ARN and then calling deploy. Notice that it is very important when you want to do monitoring that you enable data capture. And we did this as part of the Lambda function to automatically deploy the model inside a pipeline. Here, I'm just doing the same thing, but now using the SageMaker SDK. So there is a data capture config attribute that I can pass to the deploy function. And here is specified that I want to capture my data. I want 100% of all of the data that goes to the endpoint. I want 100% of that data captured. This is the destination where we are going to save that. I want requests and responses, both of those. I want to grab all of the input that goes to my endpoint and all of the responses that come out of my endpoint. In the case of data monitoring, I would only need requests because I'm not worrying about what the endpoint is answering back. That will come later when we see model monitoring. In this case, I just have the same code here, so I'm going to be capturing requests and responses. The CSV content type is going to be text CSV. That's how I want to store my information, by the way, and the JSON content types is application JSON. The reason you specify these two, or what these two properties are going to do here, is that is the content type that SageMaker is going to use to save requests and responses in that format. If you don't specify this, SageMaker is gonna create a stream. So it's gonna be like a base64 stream. I don't know what the format will be. I think it's octet stream. That's how they call it. So you're not gonna be able to read the actual request and response. By specifying these two properties, I ensure that SageMaker, if it sees CSV, it doesn't save a stream, it saves the CSV. And if it sees JSON, it saves JSON. Now that I have here, I can call deploy model to just create my endpoint. You've seen that already. Again, remember this blue warning here. It's not a warning, it's a note. Tells you that you have to uncomment this line in order for this cell to run. If you do not uncomment that line, like if you try to run that cell, it's just gonna succeed, but nothing will happen. So make sure you comment out this line. That's what the blue note is for. After deploying the model, and I'm not gonna do it now because it takes a few minutes to do, but after you deploy the model, step number 2 is generating fake traffic, right? So we want to monitor, we want to see what this looks like. So we can generate some fake traffic. And by fake traffic, what I mean is I'm gonna go through the Penguins data set that I have here locally. I'm gonna read it all in memory, and I'm gonna start sending requests to my model. I just want to generate some requests so the model has something to save in S3. This is what the generate fake traffic function is going to do. So line by line, I'm gonna go iterate through all of the rows on that data. I'm just gonna create or take all of the columns and add them in separated by commas. So I'm gonna be sending text CSV or CSV data to my endpoint. I'm gonna be calling predict using the predictor that I created before. I'm gonna be passing the payload, and I'm going to be, passing the payload, specifying that I'm sending text CSV and I'm expecting back text CSV. Okay, so I want the response to be in CSV as well. And this is important when monitoring here, because my monitoring job is going to be expecting the text to be in CSV. By the way, you could change the monitoring job to auto detect what the text is going to be and do something different. In my case, I set it up so it's ready to be handling CSV file both ways. So that is why I'm testing it with CSV here. Now, this is something new. When I send a prediction to my endpoint, I can specify an inference ID. And this is important because when we generate predictions for model monitoring, we need to find a way to match a request that went to the endpoint with a label. We're gonna talk more about that in the next session, but just keep in mind that this generate fake predictions adds that inference ID to every request. So we will see when SageMaker saves the data, we will see how that inference ID value is gonna be there. I think they call it event ID, if I don't remember correctly, in the file, in the actual content that SageMaker saves. But anyway, I'm just generating an ID, which is just the index of the row in the data set. Okay, so if I have 300 penguins, the ID of all of those requests is gonna start in 0 and it's gonna go all the way to 299. That is what the generate fake traffic is for. After you generate fake traffic, you will need to wait like a couple minutes for the data to start showing up in the capture location. The endpoint is gonna receive all of those requests, and it takes by default, I think it's a couple of minutes to start saving the files. Let's take a look at where are we saving those files. What is the location? Actually, the location is defined where we created the Lambda function. Well, I know where the location is. So let's go to the S3 bucket, and the location is within monitoring data capture. That's where I created the location to save the data. So you can see that inside data capture, which is that's the location that I'm specifying I want the data captured. There is Penguins look endpoint. There is the name of the variant that it's hosted inside that endpoint. It's all traffic, the one that I have here. 24 March, day 30, 17, 18. Let's go to 18, which is the latest one. And here you can see a JSON lines file, JSON-L file. This file was automatically created by SageMaker, and it contains requests and responses. So I have here inside session 18, after generating fake traffic, I have here a cell that is gonna go to that location. If there are files in that location, and the first time you execute this, you might run this and it might tell you there are no files, so this might succeed and it's not gonna print anything. wait a couple minutes for those files to start showing up. I'm reading the first file. Actually, I'm getting the last file in the list. So the latest file that I added to that S3 bucket, I'm gonna print it out here. So you can see this is the name of the latest file, and look at the content here. There is a section, it's called captured data. Captured data section, then there is an event metadata section. That's awesome. So let's see what we have inside. Inside we have, it says that the observed content type was text CSV. This is mode input, so this is the request. The data was, this is my CSV data that I sent as an input, and the output I'm also capturing. So you can see that the output is ADELE, that was the prediction that my model made, and you can see here that this is the confidence. This file captured both a request and the response that my model created. And you can see here there is an inference ID with number 0. So that was the first request that I created. That is the type of information that you are going to find as you start generating traffic. By the way, this file is much larger. You can just open it up. It's gonna have a ton of content inside. It's gonna have like a batch of requests and responses. This is the type of information that we want our endpoint to save. And that is exactly the type of information that we need to monitor the model. So in order to monitor the model here, I'm gonna be using monitoring jobs. So SageMaker automatically provides a data monitoring job that we can use that will automatically know how to read these files and do the comparison and generate the violations. And in the next session, I'm gonna be using a model monitoring job. Now, in order to run this data monitoring job, I need to make sure that SageMaker knows exactly how to handle my inputs and outputs and all of that good stuff. Fortunately for us, the data monitoring job supports the ability to specify a custom script that SageMaker is going to run for us to sort of like pre-process the data before SageMaker uses that data to do the comparison with the baseline. I'm going to be creating that pre-processing script, and you'll see why right now. Here, I'm just going to be creating the name of the file and saving it in the hard drive in a folder. This is where I'm gonna be creating that file. So this is what the file does. The file is very simple, and it has a pre-process handler function. By the way, you can also create a post-process or a file to run post-processing. In this file, there is a pre-process handler function, and I receive an inference record which will contain the data that SageMaker is going to be processing, and a logger that I can use to log information in CloudWatch, in the logs. What I'm doing here is I'm grabbing the input data that comes in, and I'm turning that input data into JSON. Remember, this input data is going to be in CSV format. What I'm going to receive here is something like Torgerson, 10, 20, whatever, right? 1, 0, 0, something like this. Well, I'm going to take this, I'm gonna load this, and then I'm gonna return something that looks more like this. 01, Torgerson. 02, 10, right? 03, you can see the pattern here. I'm basically turning this CSV into a JSON with an automatic name for each one of the columns. There is 01 is just a name that I'm just automatically generating here, right? You can see here that this is the label where I get the index of the property that I'm reading, and I'm padding that property with a 0 in front of it. So I'm making sure there are at least 2 characters here. So it's gonna be 01, 02, 03, right? And then I'm adding the values here. This is the output that I'm gonna be telling SageMaker to use when it processes the data internally inside the monitoring job. Something that's really important is that if I don't create this function here, SageMaker has a default way to take the input, take the output, put those two together, and they're gonna try to figure that out by default. And depending on the format of your data, that may or may not work. Remember, our endpoint might use CSV in, like the clients of our endpoint might call the endpoint passing CSV and might request JSON back, or might do CSV and CSV, or JSON and CSV. They can do that however they see fit. So you need to create this file to make sure you pass something that's consistent to SageMaker. In this case, I'm reading the CSV. I'm assuming it's always going to come in CSV because that's what my test is for. And then I'm converting that to JSON so it's consistent for SageMaker. Okay, so this is the script that I created, and I'm going to have to specify, I'm going to have to tell SageMaker, hey, use this particular script in your monitoring job. To do that, I first going to upload that script to S3 because SageMaker does not do that automatically. We've been creating custom scripts throughout all of the sessions. Unfortunately for us, SageMaker always, when you're working with a pipeline, you only need to specify the local script. And when SageMaker starts, it's going to automatically upload that script somewhere. Here it doesn't do that. So I'm gonna all of this code here, it looks like a lot of code just to do something simple. It's just for me to upload the script that I created to a specific location in S3. And I'm gonna be specifying that location when I define the monitoring job. So you'll see here that at the end of the cell, I'm basically printing out where I saved that file. So this is the location where I saved that file. So that's what I'm gonna be using when I create my monitoring job. Let's create now the monitoring schedule. That's the name of it. I'm gonna be using the class default model monitor. I'm gonna call it here data monitor. This is the type of instance that I want to run this monitor on. I'm gonna be running one instance here. The maximum runtime in seconds is gonna be 1800 seconds. Okay, so that's just, you give it a time, and after that time, SageMaker is just gonna kill that process if it hasn't finished yet. I'm giving it a maximum runtime, how much gigabytes in size I need to allocate for that process, and the specific role. Again, this is just how you specify the hardware that the monitoring schedule is gonna be using. After I have that, then here is what I create my monitoring schedule. Again, this is just a process. This is not part of the pipeline. Pipeline is over. This is just a process that you create and attach to a specific endpoint. Let's look at the properties here. I give it a name so we can identify it later. What is the endpoint that this monitoring schedule is gonna be attached to? So I'm gonna specify, well, the endpoint is this one here. It's the endpoint, the Penguins endpoint that I created before. This is important. The monitoring job, it's always attached to an endpoint. That's what the type of data is monitoring, right? So the monitoring schedule is gonna look at the endpoint that we're attaching it to, and it's gonna ask the endpoint, where are you storing your data? Where are you capturing your data? It's location ABC. I'm gonna go there, I'm gonna grab the data from there. This is the preprocessor script that we just created. This is how you specify a preprocessor script. As a reminder, I don't have it here, but you also have the ability to specify a post-processor script. If you want to log something or do something, maybe store something in the database, whatever it is, you can also create a post-processor script. So I'm passing here the S3 location of the preprocessor script that we created, and I need to specify the baseline. And in the case of data monitoring, I need to specify the statistics file and the constraints file. Where are those two files stored that represent the baseline? Because remember, our monitoring job requires the endpoint traffic. We already specified what the endpoint was, and the baseline metrics. Those are the two inputs that need to go into the data monitoring job. After that, this is how frequently are we gonna run this monitoring job? And the minimum value that you can specify is hourly. You can do it daily, weekly, monthly, etc. But I'm gonna run this monitoring job every hour. So every hour, the monitoring job is gonna kick off. It's gonna check all of the inputs and it's gonna generate more data. Then where is it gonna be storing the reports, the violations? Where is that gonna go? Well, I'm just specifying an S3 location there. And then finally, do we want to enable CloudWatch metrics? Remember, there are two ways to get the output. One is CloudWatch and the other one is the S3 location. I specified an S3 location and I'm saying, yes, please give me CloudWatch metrics so I can monitor all of those metrics through CloudWatch. So this is how I create the data monitoring schedule. Then I'm just sleeping for 10 seconds here for just a bit. So then I call the start monitoring schedule. You don't need to do this. You don't have to do this. The reason I do it is just I try to get that monitoring schedule started as soon as possible. One thing that you should understand is by saying hourly here, SageMaker is going to try to do its best to have this monitoring job run within an hour. But it might take 20 minutes up, up or down. What that means is that I might set this hourly, but that doesn't mean that in 60 minutes exactly this monitoring job is going to run. It means that it can take up to 80 minutes to run, or maybe it runs in 40 minutes. So SageMaker is going to try to do its best to keep it hourly. By just calling start here, what I've noticed is that I have a better chance of this monitoring job to run in the next 20 minutes, because I'm just saying, I'm not going to wait for the hour to come. I'm saying, just try to run it right now. Usually it doesn't start right now. So after you finish this, it's not going to start right away, but it's going to start within the next 20 minutes. Notice as well that this cell, because it creates a monitoring job, which is a resource that consumes resources, or is it a process that consumes resources, I'm just disabling the cell by default. That's important. You have to, again, remove this line here so you can actually run this. After running this, you're going to have to wait for the monitoring job to run. Again, it might take 20 minutes or whatnot while you're testing this. In a production application, this is something that you set and forget. So you just start your monitoring job and that's it. It's going to run forever. And you're not just waiting for the stuff to come through. Here, while we're testing, obviously, if you're curious and you want to see it working, you're going to have to just go and buy a coffee and then come back. After the monitoring job runs, it's going to give you a report. So down here, I have a cell that checks for violations. I created a function that deals with the checking the execution, and if the execution is completed, then display violations. So I have this in this function. This is using Boto 3, this function. I'm not gonna go line by line because it's not that interesting, but just understand that this function is just checking for the monitoring schedule, making sure it finished, and checking if there are any violations there. So I'm going to show you, I ran this before. I'm going to show you what the results were. You can see that I printed processing job status completed. At the time I printed this, the scheduling job finished doing one round. That was the latest status. So it was completed. The exit message was completed, job completed successfully with no violations, which is great. Then the time when that ran, and that was yesterday at 2:15 p.m. afternoon in my time zone. This is information about the execution. So there is a bunch of information here that you might find interesting. Like you can see, for example, the input name was baseline, and the baseline is coming from the statistics.json. You get all of the information about that, the constraints, where they come from. This is extremely helpful if you want to debug your monitoring job and you want to understand, am I passing the right information? Why not? So I'm displaying all of that. You can see where the traffic that I checked is coming from. It's coming from monitoring data capture, Penguins endpoint, all traffic, 2024-03-3017. You can see all of that here. If you scroll down, there is a lot of information that I'm printing here. And if you scroll down, you're gonna get violations and they're gonna be none. And this makes sense that there are no violations because the traffic that I'm sending to the endpoint is precisely the same data that I used to train that model, therefore that I used to generate the statistics and constraints. So that's why there are no violations. Now, as one of the assignments here, it will be a good idea to send data that's outside that baseline. So for example, try to send some data that contains body mass values that are too large or too small and see what the violations are going to say. That will be a great assignment. Let me show you something else, which is in CloudWatch, where you can see all of this stuff. So if you go to CloudWatch and have it open here, you can go to all metrics. And here in all metrics, you can find AWS SageMaker endpoints data metrics. This is sort of like this section in CloudWatch where you're gonna find the data monitoring metrics that were generated. I'm gonna click there, click in monitoring schedule, and look at all of the metrics that SageMaker is gonna be reporting on. feature non-null island, total number of violations, feature baseline drift. So if there is any drift in Coleman length, data Coleman length, non-null sex, data body max. So it's all of these logs and metrics were automatically generated by the monitoring job. Right now, there are no alarms. Obviously, I haven't set any alarms, but you can pretty much take these and print them out. Let's do 1 day. Yeah, you get here, for example, 344, and this is feature non-null island. So we received 344 islands that were not null. And that makes total sense because we didn't have any null islands. And this is total number of violations, 0. So we don't have any violations. By the way, you can just chart as many of these as you want. You can clearly see how easy it will be to create a graph and keep looking at that graph as time goes by. So every week, every day, whatever the report that you have to generate about this is, whatever the frequency is, you can come to this graph and you can see if anything is outside of what you expect. That is the power of data monitoring, where all of that is going to be happening behind the scenes. And you only need to provide SageMaker with the data SageMaker needs to do that. And it's going to be checking all of that input data for you. The next session, we're going to be focusing on model monitoring. I'll see you then.